Now let's do some hypothesis testing comparing two dependent samples. Inferences we're making from two dependent samples. So a quick reminder, independent versus dependent. Two samples are dependent if the sample values are paired. Each pair of the sample values consists of two measurements, one from the same subject, or they are matched based on some inherent relationship. So let me give you some examples. Measuring the blood pressure of 40 randomly selected male-female partners and comparing the group of men to a group of women. Those would be dependent. Measuring the weights of 20 randomly selected students at the beginning of freshman year and measuring the same group at the end of senior year. Those would be dependent on each other. Okay, let's do an example. P-value method. Listed below are the systolic blood pressure measurements taken from the right arm and the left arm of the same woman diagnosed with a partially blocked artery. Use a 0.05 significance level to test the claim that there is a difference between the measurements from the two arms. So below we have the right arm measurements are 102, 101, 94, 79, and 79. And the left arm measurements do appear higher, 175, 169, 182, 146, and 144. So the first thing that we need to worry about is the test statistic. The test statistic that we're going to start with for comparing two means from dependent samples is D bar, which is the difference, the mean of differences of each pair of data. I'll do an example in a minute. Mu sub D is the population differences of the means. SD is the standard deviation of the differences. And each one of these, the D for difference, we are going to be subtracting one paired value from the other in the same pair. So these D's stand for differences. Our null hypothesis will always be that the mean difference will be equal to 0. In other words, there is no difference. So that changes our test statistic a little bit. It simplifies it to simply T equals D bar, or the mean of differences of each pair of data, divided by the standard deviation of the differences over the square root of n in this number in the sample. So let's go back to our example. So let's say for the first pair, the right arm is 102, but the left arm was 175. The right arm in the second one was 101, and the left arm is 169. So one thing that you need to find when we're doing matched pairs is their difference. So we'll do 102 minus 175 and get negative 73 for the first difference. 101 minus 169 and get negative 68 for the second difference. Okay. So let's go to our typical steps here. The claim. The claim is that there is a difference between the measurements from the two arms. So the claim is that the mean difference is not 0. There is a difference. The opposite of that claim would be that there is no difference. The mean difference is equal to 0. As always, identify the null and alternative hypothesis next. The null hypothesis will be the one with the equality in it, so mu d equals 0, and the alternative hypothesis will be the one with the inequality in it. Mu d does not equal 0. Okay, next, the test statistic. So for our test statistic, we have d bar, which is the mean of the differences, divided by sd over the square root of n. So if we take negative 73, negative 68, negative 88, negative 67, and negative 65, and we add those numbers up, divide by 1, 2, 3, 4, 5 total, we find the mean of those differences. We should get negative 72.2. So d bar is the mean of the differences. One quick note, it doesn't matter whether you do 102 minus 175 to get negative 73? Or the other way around, 175 minus 102 to get positive 73? But it definitely matters that you stay consistent. So if you want to calculate like we did here, right arm minus left arm, make sure you do that for each one of those differences. Okay, find the standard deviation then of those numbers. So the negative 73, negative 68, negative 88, negative 67, negative 65. You need to find the mean of those to get negative 72.2 and the standard deviation of those to get 9.3133. And there are 5 samples here, 5 right arm, left arm pairs. When we plug all that in, we get a t-value of negative 17.339. If we're using the p-value method, we need to find the p-value that corresponds to that test statistic. So, using the student t-distribution table, remember this would be n equals 5, so we would have 4 degrees of freedom, a 0.05 significance level, and it's a two-tailed test. Again, this is going to be off the student t-distribution chart, but we can tell that the p-value is less than 0.01. What we care about is that p-value greater than or less than our significance level? Well, 0.01 is definitely smaller than 0.05. And since our p-value of our test statistic is less than the significance level, we reject H naught. Remember, we're on the negative side, so we are in the critical region. So that means that, remember, the null hypothesis was that there was no difference. So there does appear to be enough evidence to